This podcast is on interval notation. We're going to be using interval notation in conjunction with solutions of linear inequalities. Answers to linear inequalities will look like this: x is greater than 3, or like this: negative 4 is greater than or equal to x, or maybe something complicated like this: x is greater than negative 4 and x is less than or equal to 3. And the question is, how do we give that answer? And of course you can give it in its inequality form, which is like this, but there are two other forms of the answers, and I'd like you to do your homework giving answers in all three forms. The second form that you could give it in is graphical. In this case, x is bigger than the number 3, so your first step is to locate the number 3. Now your solutions are the x, and the x is bigger than the 3, so x is going to be to the right of the 3. So I come down here to the 3 and I arrow off to the right, and that tells me where all my x's are. The x's are all the numbers over here on the right side of 3. Now notice that it just says is greater than 3, so x can't be equal to 3. To show that it can't be equal, I put a curved bracket right through the 3, and that is the graphical answer. Now there's a third form of the answer called the interval answer. The interval answer is basically the graphical answer, but with the graph part removed, with the number line removed. So my graphical answer starts with a curved bracket. So I put a curved bracket. The curved bracket is 3, so I put a 3 right there and I put a comma. It goes all the way to the right, all the way to positive infinity. So here I put the symbol for positive infinity. Now anytime you have an infinity symbol, positive or negative, the bracket that goes with it is always curved. Now let's take a look at our second possible answer. Here's a possible answer that could happen with a linear inequality. You get the answer x is less than or equal to 3. Now, how would we graph that? Well, again, the critical number in the graph is the 3, so you locate the 3. Now in this case, x is smaller than 3. Smaller numbers are to the left, so instead of arrowing off to the right, we arrow off to the left, like so. And this time x can be smaller than 3, but x can also be equal to 3. That's what that lower bar means, that x can also be equal to 3. Now to show that x can be equal to 3, instead of putting a round bracket like we did when x could not be equal to 3, we use a square bracket. Notice in both cases the ends of the bracket point in the same direction as the arrow. Here the ends of the bracket point to the left, the arrow points to the left. Here the ends of the bracket point to the right, the arrow points to the right. Now, if you're kind of observant, you'll see that with this right arrow here, we produced a right arrow here. With the left arrow here, we produced a left arrow here. Now, that doesn't always happen. Let's take a look at example 2. Example 2 says negative 4 is greater than or equal to x. Now, the way you can tell that the negative 4 is greater is you can think of the inequality as an alligator mouth. And in this case, the alligator mouth is eating the negative 4, so that makes the negative 4 the big number. The x is the small number. Small numbers are to the left, so you will arrow to the left even though that inequality pointed to the right. The correct arrow in the graph is to the left. You can be equal, there's the equal to bar, so you use a square bracket. In the next example, we have the inequality 2 is less than x. Again, we know that 2 is less than because if you look at the alligator mouth, it's eating the x. So the x is the big number, the 2 is the small one. Big numbers go to the right, so the x is to the right this time. We are graphing x, the solution set. And x is bigger than 2, and it can't be equal to 2. So to show that it can't be equal, we use the curved rather than the squared bracket, and that would be the graphical answer there. Now going back up to example 1b, how would that interval answer look? Well, recall that we said that the interval answer was just the graph without the number line. So it's going to have a square bracket. The square bracket ends at 3, so we put a 3 there. And it goes forever to the left, so that's negative infinity, so we write negative infinity. And since we have an infinity symbol, we use an open bracket. In this case, same thing. How do you write -4 is greater than or equal to x in interval notation? Well, you have to think of the graph. The graph bracket stops at -4, so we'd have a stopping bracket at -4. It goes all the way to the left, which is -infinity, so that would be the interval notation of that answer. Those look pretty different, so you really have to think about this, and it's a good idea to draw that graph before you draw your interval notation answer. Okay, let's take a look at this one. Again, if I remove the number line, I would just have the open bracket, which contained the 2. I would go all the way to the right, that's infinity. Infinity always has a curved bracket, so that would be the answer there in 3. Now the next two example problems are quite a bit more complex, so let's go through them. In this first one, it's x is greater than -4 and less than or equal to 3. So what I'm going to do is draw two number lines, locate a -4 on the first one, and locate a 3 on the second one, putting the 0 in the same place, but to get a 3 I'll need to extend that out a little more. So -4 and 3. And let's graph the first one. It says x is bigger than -4, so the arrow goes to the right. It has to be curved because there's no equal to bar. In the second one, x is less than or equal to 3, so it's going to be a square bracket. X is smaller, so smaller is off to the left. Now, what we're trying to find is the x's that satisfy both. X's out here don't satisfy this one. X's out here don't satisfy this one. The x's that satisfy both run from here to here. So my answer set would be open bracket at -4, close bracket at 3. Now an AND statement is very much different than an OR statement. For an AND statement, the x's have to be in both intervals. That's what restricted this to -4 to 3. The solution to x is greater than -4 or x is less than 3. For x to be a member of this set, it only has to satisfy one of those. So let's redraw again both number lines. Locate the 0 in the same spot. 1, 2, 3, -4. 1, 2, 3. 1, 2, 3, -4. 1, 2, 3. Of course, we'll get the same graphs. So x is bigger than -4 and not equal, so that would be the top graph. X is less than or equal to 3, so that's a square bracket, bottom graph. And for x to be in the solution set, it only has to be in one or the other. Well, every x from infinity all the way back to here is in the first solution set, so they are all in the final solution set. And every x starting from here and going all the way to -infinity is in the second one, so they are all in the solution set. That means every x from -infinity to +infinity is in the solution set, so the solution set is -infinity to +infinity, and that completes the podcast on interval notation.